Let's see another example. We saw in a previous video, we saw a very similar one where the denominator had a negative x squared minus 4. Now we are going to do it with plus 4. And what is going to happen, the behavior is going to be radically different. So in a situation like this, first thing, we should compute the derivative. So this is 8x squared plus 4 minus 2x. Well, let's keep the order. 8x times 2x divided by x squared plus 4 to the power 2. So that is 8x squared plus 32 minus 16x squared divided by x squared plus 4 to the power 2. And that is 32 minus 8x squared divided by x squared plus 4 squared. And we can write that as 4 minus x squared divided by x squared plus 4 to the power 2. Okay. So now something we notice right away is that the derivative is positive as long as 4 minus x squared equals 0, which means x equals plus or minus 2. And then it will be positive, let's say, if and only if. So looking at the expression, we see 8, that's a positive number. X squared plus 4 to the power 2 is also a positive number. So the only thing that can be negative or positive is 4 minus x squared. So that's the only thing that matters. Okay. And that means x squared less than 4. And that means x in between -2 and 2. Okay. And it will be positive otherwise. Sorry, negative otherwise. So now we can put all this information in a sign chart. Oops, what happened there? So this is -2, and this is 2. And here we have, whenever x is less than -2, f prime of x is negative, okay? And whenever it's larger than 2, it will also be negative. I wrote positive, but I mean negative. And we saw that f prime is positive between -2 and 2. That means f increasing and f decreasing otherwise. Okay. Now, one more thing that we may notice looking at the formula for f is that f of x equals 0 if and only if x equals 0. Okay. So we can mark it here too. 0. And see what happens. So what we find here, we need another line. Let's do one line for the derivative, one line for the function. So what we are going to have is that the function is negative on the left of 0 and positive otherwise. Why? Because the function is 8x divided by x squared plus 4. Okay, so it's clear that if x is negative, then the function f of x is negative. Let me clear this. There we go. So what do we have here? So we have a function that is decreasing. Okay. And then it's increasing all the way from -2 to 2. And then it's decreasing again. So we have the point -2 that is going to be a local minimum, and the point 2, which is going to be a local maximum. Now, this function, because of the denominator being positive, this function has no vertical asymptotes. Okay. And the behavior at infinity, well, it's going to be, because the denominator overpowers the numerator, if we divide numerator and denominator by x squared, we are going to find that the limit is 0. You do the details. And at negative infinity, similar thing. Okay, and here we have all the information. We need to mark the points that we have seen were important. So we know f of 0 is 0, looking at the sign chart. And then -2 and 2, those are important also. Okay. And we have that the function is decreasing all the way to -2, then increasing all the way to 2, and then decreasing. Okay, so we can, if we want, we can evaluate f of -2 and f of 2, see what is the exact value. But let's say it's somewhere here and somewhere here. We can also say that f of x is odd. Remember the definition of odd function? That meant that f of -x equals f of negative f of x. Okay, so actually the function has symmetry. So it will be something like this. Okay. No. There we go. Then up like this, and then down and asymptotic. Okay. Remember here, something else that we are using is that we know from the sign chart that f is negative on the left of 0 and it's positive on the right of 0. Okay, so this is the only option it has.